Zigzag zoog. What are we zigzagging? Oh, it's that one leak code problem? Okay. You should find better names than zigzag and zoog. Those are bad names. This is a problem because this makes one dictionary that's shared across all instances. Whereas you want each instance of zigzag to have its own dictionary. So that's an issue. You'd want to initialize the matrix here in your init method, writing self.matrix equals curly bracket, curly bracket. If this is Python 3, you don't need these parens. Or even in Python 2, I don't think you need the parens. So drop these parens in your class declaration. So this calls zig, and this calls zig, and zig calls zag. So these are mutually recursive. Okay. They all look similar, but okay. And this is not recursive with either. So this is the entry point, I guess. You have two things called string. Well, I mean, there are not two things called string, but you have this string, and this string. They all shadow your global variable string. So that's kind of confusing because you could be looking at this code and think, oh, this string refers to this global variable. But no, it doesn't refer to the global variable, it refers to the parameter. So I would change the name of your global variable, or just delete the global variable if you don't need it. Maybe. Maybe. We'll see. We'll see what this beautiful algorithm does. Total cars. So we accumulate here. Okay. But first we zig. String. Oh, same with num levels. Num levels is a global, but it's also a parameter. So it's easy to get those confused. Another feature that's not implemented in the chat is emotes. So we're not done there. So first we zig, and then once we zig, I guess that builds the matrix. Then you do zigzag.matrix. Okay. And you get the values. Okay. And then you iterate. I mean, you don't need to build this list. You could just write for line in zigzag matrix values. You don't need to build this list, and you don't need to make a variable because you're only using this once. So you can cut out some noise by merging those lines. We look for every character in the line. If it's not, and it's a string, then you add it. Okay. Really, it's a nightmare? I haven't seen it yet. I have the emote IDs already, so hopefully it's just a matter of looking up the URL for the image. I imagine there's like 3 images or something, so I'll have to pick the right version, but I imagine it won't be too crazy. You have this else continue but there's nothing after the else continue inside this for loop, so the continue isn't really doing anything. So you can drop this else continue, drop both those lines, and you get the same effect. Mass array for every single possible emote. I don't think I'll have that problem. We'll see. This looks sketchy, this if here, but I don't know what's in the matrix or what's using it, so we'll see. Let me print your matrix. Sure. Okay, so first you call zig. So if we don't have a matrix yet, we build a matrix. Okay. And it looks like you have a bunch of dead code. Oh, no, you're modifying the line. Oh, okay. Wait, what? Okay. Okay, that makes sense. Okay. So matrix is a list from number, integer, to... It's a dictionary from integer. Let's steal your cookies here. And we are zigzag. So this is a dict from int to... Wait, you changed it since I looked at it. See, this is like this. And when I cloned it, it's like this. Wait. Oh, you gave me a different branch. Okay, that's why. Never mind, you didn't change it. So this is a dig from int to a list of... This is stir, but you also have something else. Because if it was just a list of stir, you wouldn't be doing this instance check. So we'll see what that is shortly. Yeah. Okay. So we build that thing. This you can do a bit better. In Python, let's say we got our string. Like that. Currently what you're doing, you're doing this. Instead, you could multiply a list of one thing with the length of your string to get the same thing, the list of this stuff. So if you multiply a list or a string in Python with an integer, like the length of string, so you multiply that by 14, you get one list with 14 strings, all which are the same. You could also do the same with a string. So you get 14 A's. That's just a shortcut. So let's do that in line. I'll apply your my suggestions, I guess. So we'll do that. Here I said set. Oh, so you're not using classes. You're using classes as an organization thing, not as objects. So earlier I made a comment about matrix, but you could ignore that because I didn't look at how you're using it. You're using classes in an unusual way. So level is length of string. Okay. Num levels. Okay. And for level and range, level start. Level start. So you're mutating it there. Okay. And then you don't need these parens. Usually you don't have parens for ifs. Same with down here. Drop those. So you start at that level and then you go until num levels. If the counter, which starts at 0, counter starts at 0. If the counter is less than the length, then we go, and we get the line, we say the line counter, and then you increment the counter. Okay. Otherwise you return. And then zag, level correction, is travelator. Travelator. Okay. Level start equals 1. Okay. So here you're initializing the matrix, but zig calls zag, and then zag calls zig, and then so on. Only the very first call to zig will initialize the matrix. And so instead of checking every time zig is called, you can do it on the very first call to zig over here. And then it looks more like initialization or setup work. Right? Let's run your zigzag. Beautiful printout. Oh, that's why I have the hyphens. Okay. You get a much longer if loop. What is an if loop? I mean an if statement, an if like this, an if statement, an if block. So you have, it looks like you have a counter and a travelator. And okay. So you start out by going down, and then once you've gone all the way down, you go up, and then once you've gone up, you go down and then up and then down and up. So that's what the zig and the zag are for. So I'd call this fill matrix downwards, and call this fill matrix upwards. Hello, Marco. And And instead of counter and travelator, we need to find better names for these. So line travelator is zigzag counter. So the travelator is the output index, and this counter is the input index. So this is current matrix column. And the counter is current string index. Yeah, Emmy shared the link. So this is starting to make more sense to me. So when we're going downwards, we never go to the next column, but when we go upwards, we always go to the next column. So this is not just fill matrix upwards, this is up and right. Fill matrix up and right. Can you see the question? Yeah. There's that question. So because, okay. So looking at your ifs, if you have an if and then an else, and one of the branches always returns, then you could put you can leave the return branch inside the if and put the other branch outside the if. So for here, we can move this outside the if and leave nothing there. And that will give the same output. Let's make an assertion here. Output is this. Print output. Assert output is this. So the purpose of doing that is to reduce indentation of your code. Generally, less indentation is easier to follow. Because the more, like for a human, the more indentation there is, the more conditions that you have to keep track of. Like if you're thinking, when is this line of code executed? Oh, it's if this, and if it's executed for every one of these, and it's in this func method, and that method is in this class. And the more nesting you have, the more context there is for that code. And perceptually, moving things outside of indentation can remove some of that mental load. So it doesn't actually change the meaning of the code. So it doesn't make it simpler, but it can look simpler. So that's kind of what simpler is. What does F do? Yeah, it's formatting. Well, I'm not talking about indentation or brackets. I mean, I'm saying even if you had a brackety language, you would probably use indentation, but anyway, so once you have it in this form, this looks kind of ugly because you have an empty if and you only have stuff in the else. So if you invert the condition, then you can drop the if part and only leave the else part. And this style is called early return, where you return early. So that it doesn't reduce the number of lines, but it generally is easy to follow because you can see, okay, when we when the current string index is greater than the length of the string, we're done. Rather than up here, if it's less than the length of the string, then we do something, otherwise we're done. So you're keeping the special case close to the condition, or like the behavior, the fact that we're done when we hit the end of the string. The passing the if was on purpose. It was a stepping stone to get this. Well, one problem in Python is if you have a method inside of a class, all the code inside the method, it's forced to have 2 levels of indentation. So then it's hard to have a for and an if, because this is what, 1, 2, 3, 4 levels of indentation. But at C, that's 1 less. But yeah. Oh, in the context of the method. Okay, let's. Amy, are you still there? You following along? Or did you peace out? Hey, Edema. How's it going? So we'll do the same transformation with if down here, up here that we did down here. I'll do it differently this time. So I'm going to invert the condition and then verify that that works. And then we can remove the else and unindent. So it's the same thing, just did different steps to get there. So now there's this, I mean, it's not an issue that you have mutual recursion, but the longer your string gets, the closer you get to hitting a problem. So if I make a really long string, like 1,000 times this, then you hit a recursion error, maximum recursion depth exceeded in comparison. So Python does not have tail recursion, and it has a limit on how many functions you can call deep. So here calling your zig and then zag and then zig and then zag and zigzag, and eventually Python's like, well, that's too many zigs and zags, I'm going to give up, and it throws a recursion error. So generally in Python you don't want to have too much recursion, especially based on user input. Sometimes it makes algorithms easier to write, but there are problems with it. So I did get it working. Final Spartan. It's kind of buggy. Like, Amy's profile picture is not showing up. That's not my problem. It also doesn't show up on Twitch's website for some reason. It seems like it broke. But I don't have a good replacement image, so it just is a transparent box. You can specify a larger max recursion depth. Yeah. But, I mean, I don't know if you can, but instead of working around the issue, it's better to improve the algorithm to not have recursion. So really what you could do is we want to fill downwards and then fill upwards, downwards. I spelled this wrong. Fill matrix downward. I'll just say down. Really we want to, I think it would be clear if we said fill down and then fill up right. Fill down, fill up right. So what I have in mind is over here, we say, while we're not at the end of the string, let's fill down and then fill up and right. So my goal is to write this code. And I think that's a matter of commenting out these calls that you have. And then maybe that'll work. Okay, that worked. Let's try it with the huge string. And it handled that no problem. So the huge string is fine. Because we're not doing recursion, we're not going to hit the recursion limit. We're just doing a loop, and there's no loop limit. So did you follow what I did with this while loop? Or is this too magic? Sys set recursion limit. If anything, I would lower the limit, not increase it. Did you follow, Emmy? Is your mind blown? Okay, cool. That's what? Big brain? Yeah. So turning recursion into iteration, or turning iteration recursion, takes a lot of practice. And yeah, it's just a lot of practice or experience. Sometimes recursion is better, sometimes iteration is better. It depends. But, well, first off, did you recognize that you were doing recursion? Because if you didn't recognize you were doing recursion, then you should. You should learn what recursion is and what is actually happening with the call frames. And then once you understand what's happening with the call frames, or stack frames, or I don't know what other terms people use, but once you understand what the machine is doing or what Python is doing with your recursive functions, you can make a naive, there's a general algorithm for converting any recursive function into an iterative function, which is to, instead of using Python's built-in stack, you can make your own stack. But you don't really need that here. You don't need a stack. So how did I know that you didn't need a stack? I guess because, okay, this was tail recursion. So in the case of tail recursion, so tail recursion is when you, well, I mean, Python doesn't have tail recursion, but roughly, tail recursion is when you call a function at the end of a function, or this is a tail call, roughly, because you're not processing the result of this function. You're calling the function, and then this function is done. So what Python could do, I mean, it can't do it, but in theory, what Python could do is, when it's executing this function, when it gets to here, instead of making a new stack frame and then calling this function, and then when this function returns, it goes back up here and then decides, oh, we're done. Instead of doing that, it could replace the current stack frame with a stack frame that is calling the function. And then when this thing returns, instead of returning back to fill matrix down, it would return back to whoever called fill matrix down, because we replaced fill matrix down's call frame. But it really takes a lot of experience for you to, or practice for you to understand that, of how to work with tail calls. But in the case of tail calls, if you have recursive functions that are only in tail position, so in tail position is like basically the last statement, then that's easy to, you can turn that into iteration without having a stack. Because you don't need a stack. Because you don't need to go back to where you were because you're at the end of the function, so you don't need to go back to the end of the function. So I made the mental leap to convert this recursion into iteration, and after a bit of thinking I realized, well, we could just iterate until this condition is true, in which case we can just finish our loop. Because both these functions have this check, so we can call them freely. We can overcall them. We can call them like a bunch of times extra, and it'll be fine because they all stop doing work when there's no work to do left. Like we could have said if we were a machine rewriting the code mechanically with some algorithm, or if we were doing a naive transformation and we weren't really thinking about the code, then we might do something like this, or even like this, which has the same effect. Well, no. You would need a break somewhere. But I use my brain a little too much. Anyway. Question about good practices. If the default entry point is expected to be DLL main CRT startup, should you make your own entry point named something sane like kernel main that is specified a link time, or should you use defaults even though it's ugly? How is kernel main less ugly than DLL main CRT startup? Also, what do you mean the default entry point is expected to be that? That's the entry point if you're using the CRT, but if you're not using the C runtime, then you shouldn't name it that, because that's the C runtime's function, not your function. Oh yeah, so I mentioned earlier that you could do this. You could avoid that variable. So you have this is-instance char_stir. I was wondering what that was, because when you add to your lines, you're only adding a character. So why did you need this condition? It doesn't seem necessary. Yeah, I think they're all stirs in the array. Here you can drop that, as I said, and really now there's no need to check if the matrix is empty. And here you say done. You don't need to return anything. You just not return anything. That's the same as return none. But nobody's gonna look at none of the callers here. We're calling the function, but we're not using the results. We're not saying foo equals. We're not saying print. So you could just write return to do the effective return, but not really give any. You don't care about the value. because you're returning a string, it looks like to the human that you would be using the string somewhere, but you're not, so it's just confusing. You kept getting numbers? You would get... Make sure you're using Python 3, not 2. I don't know how you would behave with Python 2. I guess Python 2 behaves correctly too. Well, at least in this version of the program, it's not giving me any numbers, so I don't know when you had that problem. Now your algorithm is all right. It uses a lot more memory than necessary, but so now we know it's only strings, so we can fix that. It uses more memory than necessary, but I mean, it's fine. It's not really yeah. Start level. So start level starts at 0. So the matrix, I'm going to improve this output here. So you have line number in matrix.keys. We're going to sort those, and we're going to print out line number and wrapper of this. Oh, Python 2. So you start there, you move over there, you start there, move over there. Okay. So why is 0? Oh, I see. So when you move up in diagonal, the last character done by that diagonal is this I. So when you want to go down again, you say you want to start at the S and not redo the I again. That makes sense. That makes sense. Improve stuff. So what if instead we stop at there? Which help range? Step is third. Okay. So stop at 0 instead and do that. Doesn't... Oh, because we need to move the column over. Let's do that. Okay. So this solution, I made fill matrix up and right not do that last character it was doing, and leave that responsibility to fill matrix down. And that means that level start is always 0. And because level start is always 0, we can just write 0. And not even have that variable anymore. So we do have this weird... This is weird. Don't know how I feel about that. So when we fill up and right, okay, so we can, yeah, I don't know, I guess that's fine. Well, we're just like moving code around. We're not fundamentally changing our algorithm. And I think your approach is fine. It's just the fewer variables they have to keep track of, I think it simplifies things. So I try to remove state. Hello XRHZ1. Also, you could do some optimizations. You don't need to keep this many hyphens. You know that the length is I guess divided by do we know how long it'll be? So here we compress 4 characters into 1, and here we compress 2 into 2, and then 4 into 1, 2 into 2. So floor of n divided by 4. I don't want to do the math, but you could probably do some math to cut out the number of hyphens, but I don't know. Okay. Well, I was thinking of not changing the algorithm at Brax, just optimizing it at surface value. Because the algorithm is fine, it gives you neat visualization for cheap. Hello world, hello world. And I said you don't need this. And if you have an empty init, you can just delete your empty init. I've heard anything about a man like, no I haven't. Who's that? Major competitions. Is this a competitive programmer? Nope. I'm not a competitive programmer kind of person. So Mbrax, you wanted to share your solution? Let's get that open. So convert word and row count. Okay. So you do the same multiplication trick. Where you can do, if you need 10 rows, then you can make a list of the empty list. The empty list being the thing you want to multiply, and then you multiply by 10. So if you wanted to make a list of ones or a list of 1, 2, 3, like the inner thing gets copied. Hopefully these examples explain it better. Do you think a strong boost gives knowledge of mathematics in programming? I don't understand your question. A boost? I don't know what you mean by boost. And what do you mean by gives knowledge of mathematics in programming? What? I don't know what knowledge of mathematics in programming means. Well, am I misparsing your sentence? I think I'm misparsing it. Do you mean, do I think a strong boost in programming gives knowledge of mathematics? Or something? I don't follow. And then we make a row iterator, and then we zip that with the word string. And then you have a row buffer, and the row, I guess that's a number from the row iterator, gives us a number. And then, so we're selecting what row to write to, okay. And then result buffer, we're extending with the row, okay. And then you make a string out of it. Okay, so all the magic comes here. So we're doing this thing, which I now know. We learned about this a few days ago. This forces all following arguments to be keyword arguments. So you have to put k equals and lower bound and upper bound equals there because of the star. If you didn't have that, then you could still do this, but these would be optional. That's just explaining it for in case anybody missed that. The current row is set to the lower bound, and then this is the direction. You flip here. So yeah, this is the direction. And k is the number of things. So why do you have a k here? Why don't you just loop forever? Because you're zipping here, so it's capped by the zip. So you could just loop forever. I think you just loop forever. You don't need to have k there. Because you're not using k anywhere else, right? Yeah. So your row iterator, drop the k variable. And it's invariant. So next row is that, if out of bounds, then yada yada, yada yada. Okay. Okay. So the way you think about it is not the way this is visualized. You're thinking about it as P, A, Y, P, and then they do A, so that's all fine. And then you put the L here, put this L here, and then you put this I here. And then you put this S after the L, so it would be in this slot. And you put the H here, and you put the I here. That makes sense. That's not how the question is phrased, but that gives you the same answer, so that makes sense. So actually, using that insight, we can change Imi's algorithm. We don't need to increment the column matrix every time. We only need to do it when we move up and when we move down. So really we need to do it at the end. So let's see what happens. Yeah, that works. So we can remove some of the dead space. The way it's phrased, it didn't remove all of it. But because with this solution, you're keeping track of a column, and you can't like keep changing the column, but we can use some of the, we can pack it more tightly than it was. So let's do that. Just rearranging stuff. Use pack that's for Emmy when he comes back. Yeah, your solution does things very differently. It works. This is a bit You might do better if you merge all these together without the intermediate lists, but maybe not. I don't know. Actually, I don't think you can do that. Well, you can use iter tools or something, but yeah. So why do you special case this? I don't think you need to special case that. It's fine that you did it, but I don't think it's necessary. Anyway, yeah, your solution looks alright. Definitely more experienced programming, but that's expected.